You ever wonder what's really holding our digital world together? I mean, all the apps, the websites, the whole thing. Well, today, we're going to pull back the curtain on the invisible architecture behind it all. We're talking about system design.
Oh, you've totally been there, right? You're rushing to snag those concert tickets, or maybe you're settling in for the big season finale, and bam, the website just dies. That feeling, that universal frustration, yep, that's a system design problem right there.
So, how do you prevent that from happening? Well, think about it like this. You'd never, ever build a skyscraper without a super detailed blueprint, would you? Of course not. And the digital world, it's exactly the same. Every single app, every website you rely on, it all starts with a master plan.
And that master plan is what we call system design. It's this whole process where engineers try to think of everything that could possibly go wrong. Their entire job is to make sure the services we use every day are built on a rock-solid foundation, and not, a house of cards that's going to collapse. Okay, so when you get right down to it, every good digital blueprint is trying to solve two huge problems. Just two. First, failure, and second, speed. Basically, you have to make sure the thing doesn't break, and you have to make sure it's fast. That's the game. So let's dive into that first one. All right, section 1, building for failure. So here's the big question. How in the world do you build something that's getting hammered by millions of users all at once and make sure it doesn't just fall apart? The number one goal here is something called reliability, and you can just think of it as a promise. A promise that when you click play, the video actually plays. When you hit send, the email actually sends. It's a system doing exactly what you expect it to do, every single time. No drama, no surprises. But let's be real. Things do go wrong. It's inevitable. And that's where the next idea, resilience, comes into play. Resilience is all about the system's ability to take a punch and just keep on going. If one piece of it fails, another piece just seamlessly takes over. The spare tire analogy is perfect. You get a flat, sure, but the trip isn't over. You're not stranded. So let's just put them side by side. Reliability is the system working just like it's supposed to. Resilience is how it recovers when it doesn't. I like to think of it like this. Reliability is the mission. It's the goal. But resilience, that's the backup plan. And you absolutely need both. You have to aim for perfection, but you have to plan for failure. Okay, great. So we've built this incredibly tough system. It never crashes. It can handle anything. Awesome. But what if it takes like 30 seconds to load a single web page? Well, then it's useless, right? Nobody's going to stick around for that. And that brings us to the second massive challenge, building for speed. Yep, our second enemy is the dreaded loading spinner. Because a system that is perfectly reliable is still a total failure if it's painfully slow. It's not just about if it works, it's about how fast it works. So the first big word you'll hear when we talk about speed is latency. But really, that's just the fancy engineering term for lag. You know exactly what this is. It's that awful little delay between you clicking something and the thing actually happening. And for system designers, pretty much their entire job is a war against latency. Now, the other side of that speed coin is throughput. If latency is about how fast it feels for you, throughput is about how much the system can handle in total. What's its total capacity? How many people can use it at the same time without things grinding to a halt? The bridge analogy is perfect here. Low throughput is like a one-lane bridge at rush hour. It's going to be a total traffic jam. And this is where you can really see how these two things, latency and throughput, work together. Just look at video streaming. If you're watching standard def, a little bit of lag is fine. It doesn't need a ton of capacity. But as you climb up to HD and then to 4K Ultra HD, whoa. Now you need critically low latency so the video starts instantly, and you need critically high throughput to pump all that data to your screen. You gotta have both, or you're just staring at that buffering circle. So, how do they do it? How do engineers achieve that perfect balance of low latency and high throughput? Well, it's not magic. It's engineering. And the good news is, they don't have to reinvent the wheel every single time. They use proven strategies. You can think of them as pre-made master plans that are designed to solve these exact kinds of problems. These master plans have a name, software architecture patterns. And it really is just like having a library of different blueprints. You wouldn't use the blueprint for a cozy little house to build a giant football stadium, right? In the exact same way, an engineer picks the right architectural pattern for the job they're trying to do. And just to give you an idea, here are two of the most common patterns. On one hand, you have the monolith. Think of this as an all-in-one application. Everything is tightly bundled together. It's simpler to get started, but if one little part breaks, the whole thing can crash. Then you have microservices. This is the opposite. It's like breaking the application down into dozens of tiny independent services. It's way more complex to manage, but the big advantage is, if one service fails, the others can just keep on chugging along. See? It's a classic trade-off between simplicity and that resilience we talked about. Okay, so let's talk about the design you use every single day. I know these ideas might sound a little abstract, a little techie, but I promise you, they are running silently in the background of pretty much everything you do online.
So why does this actually matter to you? Well, it's the reason your streaming service doesn't start buffering right at the climax of the finale. It's what keeps your online shopping cart from crashing in the middle of a huge sale. It's how your favorite game connects millions of players all at once without lagging into oblivion. At the end of the day, it's the invisible foundation of our entire modern digital world.
And that kind of leaves us with one last big question, doesn't it? As our world gets more and more connected, as our devices get smarter and smarter, what's the next great design challenge? The demands on these systems are just exploding. So you have to wonder, what kind of blueprints are we going to need for the world of tomorrow?